Cows are treated so well these days that it might just make humans jealous. See those cows in VR glasses? They don't just have them on for fun. These VR glasses are the secret tools for farmers. Happy cows give better milk, so farmers use VR to stimulate lush pastures, making cows think they're outside, not in some sterile man-made facility. And this is not just on paper. In Turkey, one farmer actually increased milk production from 5 to 7 gallons by outfitting his cows with VR glasses. So when those chubby, happy cows are being scammed by the farmers, their milk is being used to make your favorite treats like traditional French butter. In a world overflowing with high-tech advancements, one French butter maker decided to turn back the clock and revive 19th century butter-making techniques. And guess what? It worked wonders. This old-school method takes a whopping 72 hours to produce butter, which is 12 times longer than the commercial process. Yet, this painstaking technique has become the new obsession in butter houses everywhere. Curious why this 19th century secret has captured modern hearts? You'll find out soon. So, the process starts when automated machines come into play to contain the milk. This machine has several elongated cups that are attached to the cow which draw out milk through a controlled vacuum. After that, the milk passes through a quality check, and then this milk goes straight to the butter-making process. From here, the journey to have rich, flavory, and creamy French butter begins. Initially, French butter goes through the same steps as regular butter making, but there's a special secret involved before it's finished. So back to when fresh milk arrives at the butter house. It's heated at around 60 degrees Celsius. Now the goal is to separate cream from skimmed milk. If you let the milk sit at 37.7 degrees Celsius for 24 hours, the milk will naturally rise, forming cream and leaving skimmed milk behind. But can any butter factory afford to wait for such a long time? No. That's why centrifugal separator was invented. This machine spins any mixture and generates centrifugal force, which separates components based on their densities. This process causes the cream to emerge from the center top of the skimmer, while the skimmed milk comes out from the outer edge. The cream passes through the pasteurization stage, where it's heated between 65 and 95 degrees Celsius for 20 seconds to kill the microorganisms. The cream then sits comfortably for around 24 hours for maturation. Now the cream is fed into the butter to churn. What this step essentially does is to spin the cream to the extent that it separates into butter and buttercream. The churn can be of any type. A plunger churn uses a wooden barrel and a stick to spin the cream, or a paddle churn contains paddles to rotate the milk or cream. If you want a metric ton of butter, the churn is filled with 2,400 liters of cream. As it spins, the fat clumps together to form butter grains. After 30 minutes, the churn is opened and the butter grains are cleaned out with filtered buttermilk. The churn continues for another 15 to 30 minutes until all the grains turn into a single mound of butter. From here, the regular butter is turned into traditional French butter. But how? The process is really interesting. But before that, the butter rests for a day so it can absorb taste and flavor. When the regular butter reaches the mixing or kneading unit, they ensure it has already undergone fermentation. This is a secret step that makes the French butter creamy and textured. Then, the large blocks of 50 kilograms of butter are unwrapped and cut into slices using thread. Then these slices are spread into a traditional system called the malaxage technique. This 19th century technology was brought back to the modern butter houses by a French named Jean Vis. The machine contains a wooden base, a metal body, and a wooden roller over a top that runs through the butter. The purpose of this technology is to help in kneading the butter to give it a soft and smooth texture. This step also helps to remove any leftover buttermilk from the butter, ensuring that the final product is pure and smooth. But this is not like the modern machines, where everything is automated. It requires a lot of effort from human hands. It would be great if it did not require those bare hands, but the secret of fresh butter lies in this manual kneading. But it's a really difficult stage. The blog I initially told is at 50 kilograms standard, so lifting a bit of it would be around 10 kilograms. And that too in one go. These butter makers deserve all the admiration. But this trick of using the thumb to cut down the dough into two sections really helps them fold this hard and heavy butter. But how long will this kneading go? The time spent kneading the butter varies based on several factors: the butter's quality, the temperature, the weather, and what the cows are fed, like silage in winter and grass and fresh flowers in summer. In winter, it takes about 25 minutes, while in summer it only takes 15 minutes. Only traditional makers still adjust their techniques based on the seasons. Butter is like nature's blotting paper. This means it absorbs the characteristics of its environment. So, while rolling and kneading salt is sprinkled on the butter, it actually serves two purposes. One is obvious. It enhances flavor and acts as a preservative. Second, it helps butter reject all the leftover water it has on it. Once salt is added, the wooden screw rolling over the butter starts getting wet. Water starts flowing, and salt interacts with the fat molecules. The fat molecules see the salt as an attack and push out the water they contain, causing the water to drain away. With the help of salt, the butter will lose almost a liter of water. All we are left with is a dry matter. This dry matter contains fat, and fat is where the flavor comes in. But you might guess that using salt can make the butter too salty. However, this is not usually the case, as the butter does not usually get eaten straight from the burette or the mixer. It takes usually 1 to 2 days for butter to step into our kitchen, and this time is enough for the intensity of salt to diminish. Once the butter is flexible enough, each stack of freshly churned butter is placed into a machine called the pusher. This machine presses the butter through a cylinder and onto a table, where it's sliced with a guitar string cutter known as Marie Antoinette. Thanks to the 19th century device, the spacing of each guitar string cutter ensures the butter is cut to the desired weight. Now, shaping is the only step left before this heavenly taste reaches your palate. When butter has the perfect consistency, it's ready to be shaped. And just like the rest of the process, it is done entirely by hand. Butter makers use a paddle set here to help the shape. The deep grooves help remove excess butter and mold and shape the butter with precision. Each piece is custom-made to order. Some chefs might prefer bite-sized shapes, while others might buy the whole stack and cut it themselves. The butter is then packed in plastic containers to keep it fresh for as long as possible. This way, you can enjoy the genuine, wonderful taste of traditional French butter. But butter isn't the only thing you can whip up from cream. What else? Your favorite ice cream, of course. But how? The process is as satisfying as a scoop of vanilla bliss. So, it all starts with cream, which arrives at the factory in refrigerated trucks and is stored in silos, kept at a constant 4 degrees Celsius. Since cream is a dairy product, it can easily get contaminated by bacteria. So, keeping it cold during transport and storage helps keep it fresh and safe. The cream is then mixed in a high-speed mixer. These ingredients include powdered skim milk, plant-based stabilizers, emulsifiers, sugar, dried eggs, and corn syrup. The role of stabilizers here is to stop the ice cream from crystallizing, while emulsifiers help the mix bond with air during whipping, making it smooth and creamy. After about 3 minutes of mixing, the mixture is pumped into pasteurization machines, usually a plate heat exchanger. This machine has stainless steel plates with channels for the mixture to flow through, allowing for efficient heating. The mixture is heated to around 68 degrees Celsius for 30 minutes, killing any bacteria and activating the stabilizers. Next, the mixture is homogenized, a process that breaks down fat globules to give the ice cream a smooth texture. The hot mix is forced through small openings at high pressure, around 2000 to 2500 psi, to make the fat droplets small and uniform. This step is essential for preventing fats from churning in the later freezing stage. The mixture is cooled at 5 degrees Celsius and aged in refrigeration for 12 hours. This allows the mixtures to meld and the texture to stabilize. After cooling to around 4 degrees Celsius, the mixture heads to the ice cream machine. This machine works with a high-speed electric motor that spins the canister while the scraper inside spins in the opposite direction. As the canister spins, the mixture freezes against its inner wall. This freezing process causes ice crystals to form and grow larger. The machine keeps the mixtures cool at -5 to -8 degrees Celsius by circulating refrigerant around the mix constantly. During this cooldown, they might add in extras like chocolate chips or nut to make sure every scoop's got some goodness. Besides, The air continuously runs through the mixture, which makes the ice cream fluffier and increases in size by 60 to 100%. In fact, without air, the ice cream would be too hard to eat. When the crystals reach enough size and they can't get any bigger, the ice cream is ready. After that, the ice cream is filled into pint or half-gallon cartons, then dropped into holders and filled with just the right amount. As they move along, an inkjet swoops in to spray an expiration date and production code on each carton. After that, they cruise through a heat tunnel for some plastic shrink wrapping. Next up, these packaged ice cream heads to a blast freezer, where they're frozen very quickly at temperatures below -18°C. This rapid freeze keeps the ice cream tasting fresh and keeps its textures smooth. After that, you'll find them in supermarket freezers or ice cream shops, all set and waiting for someone to grab them off the shelf and enjoy. Cheese. But why are we talking about just the cream-based products? Why don't we discuss the wonders of whole milk? And when it comes to milk products, cheese tops the list. So today, let's debunk the whole process of cheese making. But before that, there's a special term for milk that's perfect for cheese that's cheese-making friendly milk. That is because cheese is highly sensitive to the quality of milk, even more than butter. It needs just the right balance of protein and fat, and it must be free from any chemical or biological contamination. So, when milk arrives at a cheese-making factories, it is heated to around 77 to 80°C to kill harmful bacteria. Then, by reducing the temperature to 32°C before further stages. Once the milk gets rid of bacteria, the cheesemakers introduce a special fermentation starter. This solution of gem culture added through a separate pipeline that actually kickstarts the cheese-making process. Hair. A type of bacteria known as mesophilic bacteria plays a key role in preparing semi-hard cheeses. So, what it really does is break down milk proteins and fat to develop the flavor, aroma, and texture of cheese. So the milk and starter combination is heated between 28 to 30°C. Why this temperature? Because it's an ideal temperature for mesophilic streptococci to thrive. Though some people think it's the bacteria that does the full job in cheese making, but it's not true. Bacteria and temperature alone won't turn milk into cheese. You need a catalytic agent called enzyme rennet. Rennet breaks down casein molecules that turn liquid milk into a gel. Adding rennet, they stir gently for 5 minutes and let it rest. Otherwise, the curd will be destroyed. If everything's okay, they proceed to cut the curd into granular pieces, separating the liquid whey, and this process also yields cottage cheese if stopped early. But right now, I am talking about regular cheese. So, the granular curd is then sent through pipelines to rotating drums for even distribution into cylindrical molds. These molds are filled to the brim and shaped into hills or hut-like structures for even distribution. After filling, the molds press the mixture for about 12 hours. This pressure serves two functions. It removes excess liquid, and second, it shapes the cheese. Here, calcium chloride is added to enhance curd density and structure. After pressing and resting overnight, it is then carefully removed from the molds, trimmed of excess, and placed in a container for brining. In the brine vat, the cheese is salted to give it a final flavor, and it matures perfectly. Then, to achieve this yellow hue, some manufacturers add a small amount of coloring agent to the finished cheese, especially in fall and winter, when cows typically don't eat green grass. So, this way you get hard and solid cheese which you melt and use. But what about cheese spread that you can apply easily on bread? For that, the process is a bit different than semi-hard cheese. It starts with mixing semi-hard cheese in a kettle along with butter, Edam cheese, milk powder, and cheese melting salt. This special salt is super important because it melts the proteins and makes sure the fat spreads evenly in the mix. Besides, it keeps the cheese spread smooth and stops it from sticking to the foil. Once mixed, the kettle is sealed and heated to 90°C, then given a secondary treatment at 140°C to get rid of harmful microorganisms again. But this process also kills beneficial microorganisms that are used in fermenting cheeses processes. This is the reason why cheese spread is considered dead compared to semi-hard varieties. Next, the semi-hard cheese spends 2 days in a brine bath before entering a drying and ripening chamber. Here, bacteria-driven process continues, much like in the aging of wine and cheese. And finally, the cheese is wrapped in a special film that allows carbon dioxide to escape while keeping oxygen out. Why so? To prevent mold and yeast growth. Yogurt. I have never tried making cheese at home, but I've attempted yogurt several times, and mine never turns out as smooth and flawless as the ones from the store. Intrigued by this, I decided to satisfy my curiosity and witness the whole process firsthand. Here's how they make it. It all starts with milk from dairy farms as always. This milk is carefully transported in refrigerated trucks to keep it fresh and stop any bad bacteria from growing. When the milk arrives at the plant, they tweak its composition before turning it into yogurt. This first step is called standardization, which involves reducing the fat and boosting the solids. This not only makes the yogurt healthier, but also keeps it smooth and firm, so it doesn't separate when stored. To trim down the fat, they use a machine called a clarifier. This machine uses centrifugal force to separate fat from milk and ensure the solid content is increased to around 16%. Then they adjust the solids by either taking out some water or adding in concentrated milk or milk powder. Next up is, you guessed it right, pasteurization. A big word for just heating the milk to about 90 degrees Celsius in huge steel tanks for 5 minutes. This kills off any bugs that could mess up the next steps. At the same time, they also homogenize the milk, which breaks down the fat blobs into tiny, even pieces. This makes the yogurt nice and smooth, so it stays that way. After, they create bubbles in the milk to break down any leftover fat. Once the milk is ready, they cool it down to 38 to 42 degrees Celsius and add in special cultures that turn it into yogurt during a few hours of sitting. The culture is often a mixture of Streptococcus thermophilus and Lactobacillus bulgaricus at a concentration of about 2%. These microbes change the milk into a thicker curd and give yogurt its tangy taste. Lactic acid is also used, which tells when the yogurt is done. At this stage, the temperature is kept uniform for about 4 to 6 hours to get a good flavory product. To make it sweeter or smoother, from which of course they do, they add sugar, which is added around 7%, artificial sweeteners or cream. Starch, gelatin, or gums can also be added as stabilizers. After that, when a pH of 4.5 is attained, the yogurt is cooled down at less than 30 degrees Celsius to avoid access to acid production. If it's frozen yogurt, it goes through a freezing process using specialized equipment, just like the commercial ice cream machines mentioned earlier. These machines not only freeze the yogurt, but also whip it in the air to give it a light and creamy texture. Once frozen, the yogurt is carefully packaged into different types of containers like individual cups, large tubs, or pouches. This choice depends on what customers prefer, how long the yogurt needs to stay fresh, and how it will be used. After packaging, the yogurt containers are stored in cold storage facilities. That's how yogurt goes from farm to fridge. And that's how I bring the making of your favorite treats to your knowledge. If you liked this video, hit the like button and tell me which of the processes you found most interesting in the comment section.